Hello viewers, welcome back to our YouTube channel, and today we want to look at what we call the box and Whikser plot. Box and Whikser plot. Box and Whikser plots. Most of the time they call them box plots. Of course, the box and Whikser plots, they are mostly used to represent what we call the quartiles. They are used to represent what we call the quartiles. They are used to represent the quartiles. Of course, the quartiles, they include the lower quartile, the upper quartile, and then they are what we call the semi-interquartile. Interquartile ranges. Of course, we are going to look at some of these, and I know, of course, we have not looked at the measure of dispersion and then the measure of central tendency. But as we get to those aspects, we shall look at what we call the median. We'll look at the quartiles, both the interquartile and then the upper quartiles. So a box and Whikser plot, a box and Whikser plot, as I've said, they are basically, most of the times they are always called the box plots. Of course, a box plot is an exploratory data analysis tool that highlights the important features of a data set. So they try to give out the different features of a given data set, and for you to be able to graph a box and Whikser plot, there are values that you need, or that there are values that you must first compute, or that you must identify if you are to compute, or if you are to graph your box and Whikser plot. I don't want to go into so much about the details of the theoretical aspects, but I just want to go straight to the things that we need to do for us to be able to draw a box and Whikser plot. As I said, there are 5 values that you need to know. The first value, of course, it's called the minimum entry. Minimum entry, and this is the smallest value. So in the data set that has been given to you, you have to first of all arrange this data in an ascending order. Second of it all, you pick out the first number, and that will be the minimum entry, or the minimum number, or the smallest value in the data set that has been given to you. Number 2, we have the first quartile. First quartile. Of course, the first quartile is that Q1, we call it Q1, which is the lower quartile. Remember, we told you that the box plot is used to record entries, to record quartiles The third number that you need to know is the median. And of course the median, that is our Q2 or quartile 2 or the second quartile, which is the middle number. The middle number, or that number that is in the middle. Then the fourth one, the fourth number that you must know is the third quartile. Third quartile. Third quartile. Third quartile, which we call the Q3. This is the upper. Of course, this is the upper quartile. Of course, this one is the middle or the second quartile, the median. Then the last one, of course, we look at what we call the maximum entry. The maximum entry is the same as the largest value or the highest value in the data set. But of course, we shall try to bring in other aspects, like if there are outliers, what happens? Of course, we may say that this is actually the highest value, but you find that in the data set that has been given to us, we have maybe outliers. So the question is, what will be the impact of an outlier on the data set? So let's first write the third, the fourth, the fifth, number 5. And number 5, we said it is all about the maximum entry or the largest value. But we have to be very careful when we are looking at these the largest and then the smallest, because most of the times these are going to be affected by outliers. But if we have a data set that doesn't have anything to do with outliers, the minimum and then the maximum, they will not have so much impact, or they will not be affected by anything. But regardless of whether we have outliers or we don't have outliers, in any given data set, you must identify these 5 numbers. And these 5 numbers, they call them the 5-number summary. 5-number summary of any given data set. So once you have identified this 5-number summary of a data set, then you can be able to go ahead and draw a box plot or a box and Whikser plot. So let's look at now the steps. The steps for drawing a Whikser plot, a box plot or a box and Whikser plot. Steps for drawing a box plot or a box and Whikser plot. Of course, our step number 1. Step number 1 is all about to find the first 5 numbers. And when you are finding out these first 5 numbers, you will see that you will have to first arrange the data in an ascending order. because from there it will be very easy for you to be able to identify those numbers. So my first step is going to be to arrange the data, arrange the data set in an ascending. It's always arranged in an ascending order, not descending, but you start with the smallest and then you end with the largest. That is the first step. You arrange the data in what we call the ascending order. Then the second step, of course, the second step is now to find the first 5 number summary of the data set. So those are the 5 numbers that you must know. So the second, we say that the second is actually to find the 5 number summary. Find the 5 number summary. Find the 5 number summary of the data set. It is very important. If you can't do this, then you will not be able to draw a box and Whikser plot. Number 3 is for you to construct a horizontal scale that spans or that moves or covers, spans the range of the data, spans the range of the data. So you have to construct, just like the way you construct a number line, it will be the same thing. You will draw that horizontal line, but you make sure that this horizontal line is going to cover the entire data set. How are you going to know that I have covered the entire data set? Is because in this first step you identified the first 5 number summary, where you looked at the minimum number, that is the smallest, and then the maximum number, which is the largest number in the data set. So you make sure that the scale you use should be able to fit all these values that we have seen in the distribution. So we said when you're finding these 5 number summary, you start with the smallest number, or that's the minimum entry. You look at the quartile, the first quartile, which is the lower quartile, and then you look at the median, which is the second quartile, and then the third quartile. We shall understand more on what to do with quartiles, but one thing you have to understand is that this is just a diagram. I'm going to give you the illustration, then we look at an example where we have both the maximum and then the minimum, but within those very numbers we have what we call outliers, and we shall see how we identify those outliers. So the number 2 was to the number 3 was to construct the horizontal scale that will span the range of the data. Then the number 4 is of course to plot you plot the five number summary, or the five numbers. You plot the five numbers above the horizontal, the horizontal scale. You plot the five numbers above the horizontal scale. Then number five is for us to draw a box, above the horizontal scale, we draw a box above the horizontal scale. We draw a box above the horizontal scale. Draw a box above the horizontal scale. Of course, we draw it on both sides. I will show you how we draw this. It moves from some point, then it ends at some point. We draw the horizontal scale. Of course, it moves from a sum from it moves from the lower quartile, or the smallest value, which is our Q1, the lower quartile. It moves from our lower quartile to the upper quartile. Which is the Q3. And of course, and then we draw a vertical line. We draw a vertical line in the box. We draw a vertical line in the box at both points. Then finally, of course, these are the ones now we connect with what we call the wicks, or the Whiksers, from the box to the minimum, and then from the box to the maximum entries. So the last one, let me use a different color. Number 6 is for us to draw Whiksers from the box to the minimum, 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 and maximum entries, meaning these lines will be they will be connecting from both sides, both sides of the graph. So we are going now to look at how it's going to look like. We name these, then we'll be able to draw them using an illustration. Of course, we are going to pick one practical example, then we go through it. So we are going now to have a box and Whikser plot. We look at how it looks like, then we'll be able to use an example to illustrate what we are talking about. It looks like the way you're seeing me drawing it. We said we'll draw a box. We said we first draw a number, like we draw a horizontal scale like that. And of course, on this horizontal scale, we are going to have numbers. We will have numbers on each of these items. We shall have numbers all the way like that. Now, what is going to happen is that we are going to plot our numbers, and these numbers, we said we plot the minimum. Of course, remember we said these numbers are going to be arranged in the order. So the minimum, we shall assume that maybe this is our minimum. Let me just use a different color. If this is our minimum and it is here, of course this will be our minimum. Let's assume it is at the extreme end. Okay, let's just take that one, meaning this is Q1. That is the lower, no, sorry, this is our minimum. Sorry about that. This is our minimum value, like the smallest value. And you find that the smallest value starts from here. Now, the second thing that we find in the 5 numbers is the lower quartile. Of course, the lower quartile will be this point here. Here. This will be our Q1. Now, the third thing that we get is the minimum, or the second quartile, that is the median. It is within the middle here. Let's assume this is our median. So that this will be our number, the median. Then this was our quartile, first quartile. Now, the next thing that we are going to do is for us to find the third quartile, which is the upper quartile. It will be around here. This is our, so this is our Q2. This is our Q3, the third quartile. Then the last number that we plot is the maximum value. Let's assume that the maximum value is at this point. This is our maximum value. So we can label these values. We say that this, let's label this is our minimum entry, or smallest value. Then this is our maximum entry. Now, what we do, we said we draw a box, and the box is going to be connecting from the lower quartile to the upper quartile. We draw it like the way you're seeing here. This is the box that we talked about. This is the box plot. That is the box. So this will be the box. We can actually shade it. Maybe we can shade it with blue. This is our box. So that's our box. Now, the last, we've said that the once we have drawn the box, the last step is for us to draw what we call the wicks. The wicks are the ones, or the wicksers are the ones that are connecting the median, they are the ones that are connecting the minimum entry and the maximum entry to the box. So how do we draw them? We just connect, it is just a line connecting those two values. So let me try to use a different color. Maybe let me use this. So we draw a line, it connects these two values, it connects the minimum and then the maximum. Then we also draw a line that connects the smallest, the largest value to the box. So these are the ones that we call the wicks, the wicksers. These are the wickser. So that's why they call it wicks, a box and Whikser plot, because it is a combination of a box that we have seen, which is this, and then the wicksers that we have seen, which are these ones. So the shape that you are seeing in here, from here to here, that's what we are going to be drawing. This you are seeing here is the one that we are going to be drawing. So we need now to pick maybe a practical question, and then we look at the computations that are behind it, and as well as looking at how can we be able to draw this on a graph. Sometimes you can draw it on a graph, sometimes you may draw using just on a plain paper, but it's better when you have put it on a graph. So we are just going to have just numbers. We can have some few numbers, then we'll be able to but the other thing that we are going to talk about as well, we said we are also going to look at the fact that we needed to do a number that includes outliers. Then we see how do we know that these are actually outliers, and how these outliers are actually going to affect both the minimum and then the maximum values. Of course, for the outliers, maybe something I never wanted to go theoretically, but let's talk about a brief aspect to do with the outliers, and maybe what, so that we shed a picture of what we think is going to happen if in the data set we have what we call outliers. So outliers, that's how they write it, that's how it's written, outliers. Of course, outliers, these are extremely high or extremely low data values, extremely high or extremely low data values in a given data set, in a given data set, extremely high or extremely low values in a given data set, So these values are going to be either too small or too big as compared to the rest of the data set that we have been given to us. So these extreme values are the ones that we call outliers. And an outlier is just a data entry that is far away, or it is far removed from the other entries in the data set. It is either going to be too small to be compared to other data values, or it is too big to be compared to other data values. So they are a distance away from the rest of the values that have been given to us in the data set. Now, a data set that has maybe one or two or more outliers, it's going to cause what we call gaps in the distribution. They are going to cause what we call gaps in the distribution. We are going to find that we might have maybe, let's say, -1, and the next value that we have is, let's say, 1,000. Honestly speaking, from -1 to 1,000, for sure, you are going to see that this negative is actually far away from the next value, which is 1,000. And if the value was maybe -1, 1,000, then someone comes and includes a figure of, let's say, 10 million. And these other values, maybe they are stopping at, let's say, 1 million. So you will see that these 10 million and this -1, they are too far away from the rest of the values. So those are the ones that we call outliers. But in a question, it is a little bit hard for you to identify these values. But we always have, because even when the values seem to be not so much deviating from each other so much, but if we do some computations, we can be able to identify that this is an outlier, because we know how to compute both the lower and then the upper values, or the upper limits. We are going to look at some of these. We are going to pick a question, then we see what is going to happen. So one thing that we have said, it causes a gap, it causes gaps. Just imagine if we are to plot this graph, you will see that in between 1 million and 10 million, there will be nothing. You will not be having any value that you have plotted there, but it will just have a gap left there within the distribution or within the data set. So the conclusion that we draw from such a data set that contains outliers, of course we are going to find that in terms of making computations, like if you're finding the mean, if I want to look at the mean data of something that has maybe 10 million and the next value is 1 million, then the next value is 1,000 and -1, you'll find that the mean is going to be a figure that is going to be also far away from these other values, because you'll find that these outliers are causing the mean to be high even when it wouldn't be. So it has, these outliers have what you call a striking effect on the mean of the data set. So with that reason, of course, we try to analyze the frequency distribution and then you, as you are trying to analyze it, you make sure that you be aware of any of such values, either they are too small or they are too big, because for any data set, the mean, median, and then the mode, those are the measure of central tendency. Of course, they are going to be quite different because of these extreme values, or what we call the outliers. But we use what we call the interquartile range. We use the interquartile range to be able to identify outliers. And at the same time, we can also use the box plot, because if you see that the maximum, of course, the maximum value from here, it will be the 10, this 10 million will be the maximum value, then the minimum value will be -1. So you will see that you are going to have a longer Whikser plot. You are going to have Whiksers which are longer, because of the fact that the distribution is not, the distribution of the data set is not evenly distributed. Like the numbers are not all that close to each other. But we know that if you are not dealing with small, maybe small companies or small data set, you may not be able to use some of these, like the box plot. If you are looking at data set that is going to have maybe very many companies, you will find that you'll be able to use these other procedures. Of course, let's now just look at the question. We get, maybe we pick one questions, then we try to solve it, and we see what we have got, what we have to do. So simulation can say that the following are scores of students in their economics test. So we are going to give these values. We are going to just list them. We have 15, 20, 5, 16, 25, 26, 21, 27, 30, 31, 30, 32, 34, 32, 35, 38, 38, can put maybe 41, 41, so 41, 38, 38, 43, 66. Of course, we can also add 80 and maybe 100. Of course, now the required is for us to obtain both limits, the upper limits and then the lower limits. This is part A. Of course, part B, they want us to determine possible outliers, and then part C, they want us to draw a box plot. So that's the question that we have. They have given us the data set, and of course, one of the things that we talked about from the steps, we said the first step is for us to arrange the data in an ascending order. We arrange the data in an ascending order. We arrange the data in an ascending order. So let's start arranging the data. Of course, we have seen the data has a 5 as the smallest value. Solution. We've seen that the first step is to arrange the data in ascending order. So we start with the 5. Then the second smallest is 15. We had a 16. We had 20. We also had 21. We didn't have 22 and 23, so we had a 25. We never had even a 24. We had a 26. We had a 27. 30 was there twice, so 30, 30. Then 32 was also there twice. Then the other one is 32. We also had a 34. We never had a 33. We had a 35. We had a 38 twice. We had a 41, 43, 66, and then of course the other last values. The last values were in a good order. We had 66, 80, and 100. So 80 and 100. And finally 100. So those were values, and now we have arranged these values in order. So these values, if you count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. I hope we have not skipped any the values. Let's look at the values. Let's count this as well. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. These are 22. Which one did we skip? We skipped 34. Here we had 34. So let's include that 34. There is something that I want you to get, that we shall learn more. The 34 is already there. Which number did we skip? The 34 is there. We skipped 31. We skipped 31. So let's include the 31. But instead of us taking, because now since we have already arranged this in order, let's just change this value. Something small that I want to show you. Let's maybe call it, let's call it this one 131. Yeah, let's just add a 1 here to make it 131. 131. So let's go this side, we include that value. I want these figures when they are even, when they are evenly distributed. Let's add 131. 131 there, so that they are now 22. Now they are 22, and we want to know the middle point. Of course, we can start. Let's start with our first five the 5 numbers. The 5 number summary, where we start with the smallest value. Smallest value, or the minimum. Smallest value, of course, it is a 5. This 5 is the smallest value. Smallest value is a 5. The smallest value is a 5. Smallest value is equal to 5. Then let's look at the median. We have counted these numbers and they gave us a total of 22. This is the median. Of course, we have a formula for getting a median for both when the values are odd and when they are even. We shall look at that when we go to measure of central tendency. But this is what I want you to know. If we want to know the middle number or the middle value, the number in the middle, we just get the number of items, then we divide by 2. I'm just giving you a small idea of how we get the middle point, something that is in the middle. It is that item that is in between. What is on the left is equal to what is on the right. So we counted when there were 22 items. So if you divide by 2, you will get 11. Meaning our median is that number that is in the middle of 11 items on the right and then 11 items on the left. So let's try to trace that number. We are going to count 11 from the right hand side and then 11 from the left hand side, but you do that when you have arranged the values in their ascending order. So we count 11 from right and then 11 from the left. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we move from now the left to the right. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, meaning the number is in between here, but there is no number that is there. If they were odd, we would count. If these items were maybe 23, that number that would be left there would be our median. But now here we have no numbers. So you want to mean that we don't have the middle value? Of course not. The middle value will be these two numbers, this one and this one. They are the two numbers that are in the middle. If you count what has been left this side and this side, they will all be equal. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are taking these two numbers to represent our midpoint. So those are the two numbers that are in the middle, and those two, they are the ones to form our Q2, or our median or our median value, or our median scores, because these were scores. So that's how we would get our median. So our median would be, so what we just did, we lost one item on the right and then one item on the left. We took the numbers were 32 plus 32, then we divide this by 2, because these are the two numbers in the middle. Of course, this will be 64 divided by 2, that will give you 32, meaning our Q2 is actually the median, or what we call the Q2, is equal to 32. Now, I want us to look at the Q1. How do we get the Q1? There is a very big reason as to why I started with the median instead of starting with the Q1. Now, for the Q1, we are now moving in the left. We have divided these values, and we have said this and this, they represent our median. So this and this are our Q2. Now, what is left this side will give us the Q1. So we also count how many are left this side. There are 5. They are 10. We counted, there were 10. We also look at the value that is in the middle. So move 5 ways. This 1, 2, 3, 4, 5. Then also this side 1, 2, 3, 4, 5. So we are also going to take two numbers. So meaning we counted 5 and we found that it is in between. It is in here. The value that we are looking for is in between here. This will be our Q1. So we take these two, this one and this one. So we go and compute the Q1. We say that for Q1, or the lower quartile, this is a quartile, it's not a limit, it's a lower quartile. it's also going to be those two values. If you are dealing with odd numbers, it will be easy. That's why I wanted us to look at a scenario where we are focusing on numbers that are not. So we've picked 21 and 25. So we add these two. 21 plus 25 divided by 2. Of course, this one is giving us that is 46 divided by 2, and that gives you a 23. It gives you a 23. So the true one is actually 23. This is the lower quartile, is equal to 23. So we go and compute now the upper quartile. So we check out in the last quadrant. Of course, we are splitting this information into 4 items, 4 sections. So we also count the items that are left this side. This is, we say, we also counted, and there were 10. So we are picking, we count 4 from the right, then 4 from the left. So this is 1, 2, 3, 4. So this, then we also count 1, 2, 3, 4, and this. So it is a 41 and a 41 and a 43 will be forming our Q3. These two are forming our Q1, then these two are forming our Q2. Of course, the lowest was 5, and then the highest is 131. So let's go and complete. It's 42, 41 plus 43. This is now the upper quartile. The upper quartile is 41 plus 43 divided by 2. It will also give us the number that is in the middle. Of course, this is 84. 84 divided by 2. 84 divided by 2. It gives us a 42. So this gives us a 42. And this is our quartile, or Q3. Of course, we have seen that the highest value is the highest value we have seen it is 130, 131. But since we have possibility of having outliers, what we do is, for us to first wait to, okay, we are going to indicate it, but we shall give the final figures. The maximum entry as per the data set is 131. but this is not a conclusive value because we need to check whether they are outliers, and the maximum value cannot be an outlier. Now, how do we check for outliers? So this is checking for outliers. Checking outliers. We are checking now the extreme values, and this is our part, course part B, where we are confirming the outliers. We say that when you are confirming the outliers, we always use the interquartile range, not the same interquartile, but interquartile range. We are going to look at the computation of some of these for both the grouped and ungrouped data, the interquartile range, when we look at the measure of dispersion. But for now, just understand that we use the interquartile range to compute what we call the, to tell whether we have outliers or we don't have outliers. So we use interquartile range. And interquartile range, the interquartile range, we know what a range is. Of course, a range is a difference. But now this difference between the highest and the lowest is between the highest in the highest quartile minus the lowest quartile. So we are getting Q3 minus Q1, because this is the Q3 is the upper quartile minus the lower quartile. Now, the interquartile range, the Q3, the one we computed, was 42. Then the Q1 was 23. So when you, of course, you subtract, you get a difference of 19. This difference is what we call the interquartile range, IQR. These abbreviations are known. You can also use them. Interquartile range is equal to 19. Now, how do we get the values? Remember, our part 1 wanted us to compute what we call the limits. So it's these limits that are going to tell us whether we have outliers or we don't have it. So even if they had not asked about computing limits, it's a must we have to compute the limits, because that's the only way we shall be able to know whether they are outliers or they are not. So the moment they tell you to determine the outliers or to find whether they are outliers, you have to compute what we call both. You compute the upper and then the lower limits. We compute the upper and the lower limits. They are not quartiles, but they are limits. So how do we get the upper? For upper, I'm going to use U. Let me use letter U. Upper limit is equivalent to Q3, that is the upper quartile, plus 1.5 times the interquartile range, IQR. Then for the lower quartile, I'm going to use L. This is lower quartile, the lower limit. The lower limit is equivalent to the Q1, which is the lower quartile range, lower quartile, plus, for the lower, we are subtracting, we deduct the 1.5. So this one is going to be minus, it is 2.1 minus 1.5 times the interquartile range. So these are the two conditions that we use to find whether we have the outliers or we don't have the outliers. And once we have seen that we either have the outliers or we don't have the outliers, then we can be able to determine which one is the minimum and which one is the maximum values. So for the upper quartile, let me start with the upper quartile. We said it is the upper quartile. This is the upper limit. We said it is the upper quartile which was 42 plus, of course, 1.5 times the interquartile. We computed it as 19. So this is 42 plus 1.5 times 19. It gives you 28.5. So 28.5 plus the 42, it gives you 70.5. Now what this means is that this is the upper limit that they asked us in part A. Now, of course, this is equivalent because you look at the data set. The data set that was given to us has no points, so you can round off to a 71. But if the data set that was given to you had decimal points, then you maintain the decimal point that has been given to you in the question. Now, any number that is above 71 is an outlier. Any number that is above 71 is going to be an outlier, meaning that will be an extreme value on the right hand side. In other words, in the positive values, it will be the highest. So any value that will exceed 71 will be an outlier. So let's compute now the lower quartile. The lower quartile tells us the extreme values that are on the left hand, or that are moving towards the negative direction. The extreme values that are too small. So the L, which is the lower quartile, is actually, we computed the lower quartile and it was 23 minus 1.5 times the outlier times the interquartile range, which was 19. The interquartile range was 19, was multiply 19 times 1.5, it gave us 28. It gave us 28.5. Now 23 minus 28 points, it gives us a negative 23 minus 28.5, it gives us a negative 5.5, meaning any value that is below this number is an outlier. Of course, this is equivalent to negative 6. So any number that is below negative 6 is an outlier. Now, once you have computed this, Let's first state our outliers, whether they are extreme or whether they are extremely too small or they are extremely high. Now, the outliers that we have 80 is an outlier. We had 100 and 131. These are the only outliers we have because we never had negative values or negative scores. Our smallest score was 5. So it means 5 is okay. So if the examiner asks you that give me the let's assume that the lower quartile here, the lower limit, something I want to explain. If this was a positive 6, this lower limit, if this lower limit was a positive 6, and when you come to our data set that they gave us, you find that we had a 5. That 5 will be an outlier in here. If our lower limit was a 6, then this 5 would have been an outlier. So the big question is, what will, if 6 was an outlier, what would be, or what would have been our, this 5 was our minimum value, but since it is an outlier, it can't be a minimum value. So what you do, you pick the next value. Meaning, if 6 was our lower limit, so this 5 would be an outlier, and an outlier can't be a minimum or a maximum value. So the implication is that we would have chosen 15 to be our minimum value. Yes, because the 5 would have been too small if the lower limit was a 6. But since the lower limit was a negative, then it is true that 5 is actually our minimum entry. Now we go to the upper limit. The upper limit was a 71, and any value that is above becomes an outlier or an extremely high or higher value. So we picked 80 to be an outlier. We picked 80 to be an outlier. We picked 100, and we also picked 131. But remember, we said that an outlier cannot be within our distribution. So what are we going to do here? We remove our maximum value from this 5 number entry, from this 5 number value or 5 number summary. We had chosen 131 to be our maximum value before computing the outlier. But since 131 and 100 then the 80 were outliers, we can't pick them as our maximum value. So we pick the next value of it, which means that our 66 is actually our maximum value. The reason that's why we pick 66 is because these other values are outliers. And the big question is, how do I present this information on a box plot or a box and Whikser plot? So we've seen that for you to be able to draw a box and Whikser plot, you must identify the 5 number values or the 5 number summary, which we have identified. We have taken 5 to be our minimum entry. We have taken 66 to be our maximum entry. Reason because these others are outliers. Then we also have the lower quartile, the upper quartile, and then the middle or the median value. So let's now go to our part C of the question of how are we going to be able to draw the box plot. So we can summarize maybe we can summarize our information. We have said the minimum, because this is what we need. The minimum entry is 5. Then the maximum entry is 66. Our Q1 is 23. Our Q2 let me look at it. That was our middle point. Middle point was 32 because we got 32 plus 32 divided by 2. This actually was 32. Yes, we can confirm it. The middle value or the median. Our Q2, this was the lower quartile was 23, then the median was 32. Then this one was 23, and lastly this one was 42. So we go ahead to bring these values here. This was 32, and then our third quartile Q3 is actually 42. So once we have these values, then we can be able to draw a box plot. One key thing that I want you to understand from this, when we are drawing a box plot that has outliers, is that the outliers are not drawn on the box plot. We don't just leave them out, but we highlight them with the stars. We just make a highlight of them. So the first thing is for you to get a scale. You get a scale because these values we are moving up to 130. They are all positive, so we don't have negatives. So we are moving up to 131. But me, I'm only going to indicate values that are important. I'm going to indicate, but for you get a scale, an appropriate scale, depending on your graph. Maybe you can say 1 centimeter to represent 10, because I know we can actually get, yeah, each 1 centimeter can represent 10. Maybe we can try, let's try and see if we can manage that. Maybe like that. For me, I've managed to only get 10. So I can say that this is actually 1 centimeter. For me, I can use 1 centimeter to represent 20. So this would be 20. But if you're using a graph, you can take that. This is 40, this is 60, this is 80, this is 100, 120, 130. No, this is 140. 140. So those can be enough for me. Now we are going to plot these 5 numbers. Of course, the 5 will be around here. Let me assume it's around there. That's where I have the minimum value. Then the quartile is 23. So it's around there. Let me assume it's around there. The lower quartile. The upper quartile was the 32. This is going to be congested. Let me plot the numbers, just the numbers, because I'm seeing it's going to be a little bit congested. So I'm just going to plot, let's say this, I'm just going to call it this 10. I'm just going to indicate numbers. Maybe this is 40. This is, let's say, 60. This is 70. So this is 70. This is 130. Just I'm indicating the numbers. So we plot the first one. Of course, we said this is the minimum. Let me change the color. I plot, this is the minimum entry. This is now, of course, the lower quartile was 23. Let me assume it's around here. Then that's the lower quartile. Then the middle, which was 32. Let me assume the midpoint is around there. Then the other one is 42. Let me assume 42 is around there. And then lastly, the maximum, it was a 66. Let me assume it's there. Now we draw a box from the lower quartile to the upper quartile. That's how it will be. So I can shade the inner part. Then of course I draw the Whikser. We said the Whikser, they are moving from the minimum value or the minimum entry and they touch the box. So we are moving like this. As long as we touch the box, then also this side, from the maximum, then we touch the box. Now we put the outliers. Outliers, we just indicate them with a star. We just put a star to show that that's an outlier. There is one that was 80. There is one that was 100. Let me assume it was there. Then the 130. This is how you draw those. That's how you draw a box plot. Of course, this will indicate the Q2, which was a 32. This will indicate the Q3, which was equal to 42. And this will indicate a Q1, which was equal to 23. And that's how we draw. Of course, these and now the outliers. If we had even an outlier this side, we would just indicate it with a star. And that's how you draw the box plot. Now, there are other books. Of course, you are going to find other books that are going to draw as I've said, you are going to find some books and you find maybe they have drawn their box plot in this format. Doesn't mean that they are wrong. No. They are going to put they're just going to show a scale, maybe moving like this, and maybe that way. Then they come here, they put a dot, that they start plotting for like that. Maybe that's their minimum entry. Then they come to the Q1, that's the lower quartile, maybe it's around there. Then they go to the median, maybe it's in the middle here. Then they go to the upper quartile, and maybe it's around there. Then finally they conclude with the maximum value, maybe it's around there. And then they draw within here, they will draw their box, of course in the same way, but it's not in the line. They draw their box like that, and of course this one is showing the Q1. Then they come and they draw the wicks like that, So even this one is the right thing. It's not wrong. Then they come for the outliers, they just indicate them. If it is here, if it's here, if it's here, they indicate them like that. Of course, here they always draw to show that this is where it starts and this is where it starts. Of course, these circles may not be there. I've just put the circles, but these circles are not always there. So, if you find when they have drawn it like that, it's not wrong. It's just they have raised it a little bit up to be able to indicate the graph well. But here, these items, they will always name them that these are outliers. They will show those stars as outliers. So when you plot, make sure you identify that these are actually outliers, so that you don't just leave them in the table. So that's all that I wanted us to get as far as the box and Whikser plot are concerned, plus scenarios when we have outliers and when we don't have outliers. If we never had outliers, this maximum value would extend up to 131. The wicks would be very long, that it would extend to the other value. So of course, if you are interpreting some of these graphs, you look at, are there outliers? If the outliers are not there, then it is going to be easy for you to explain such graphs. if the outliers are there, if this, maybe we never had these outliers, if we never had these outliers, the implication would be that this maximum value would be this end. The implication would be that this one, we would have very many values at the right hand side as opposed to the opposite side. Because even when you look at here, from here to here is smaller than from here to here. So you find ways on how you can explain the data depending on what they have given to you. Maybe you can say that most of the students scored. Maybe if you look at that maybe most students scored maybe less than 60, or most scored more than 50, depending on how many number of people are on the right hand side and how many are on the left hand side, depending on their scores. Because you may find that you have more data concentrating on the left hand side and then less data concentrating on the right hand side. But we always do such kind of analysis when we go to, of course, when maybe we are looking at the skewness, of which that's a topic that we shall handle when we have finished measure of central tendency, we have finished measure of dispersion, and we proceed to skewness to look at how the data is skewed, either to the left or to the right, or it's a normal thing, or it's a kurtosis. So those are the things that we look at when we reach there.